Okay, so we should be live, I guess. Copy Twitter live forming app for the Microsoft. Competition. Quantum computing. So I'm just sharing these in Twitter. And I guess we'll. Yeah. Let's see if I can put the. So the chat is visible. Okay, cool. So just be waiting a little bit, see if anyone else joins. I don't have much time, to be honest. I hope the audio is getting in well as well. Um, I just wanted to kind of see because I'm gonna try to take part of the competition next week or whenever it is, and just want to take a look at the warm up exercises. I know I've seen this quite a lot, and I don't think that I'm gonna be able to go through all of them. I just wanted to get used to the Q sharp thing, which seems to be a bit more complicated than I expected. Um, Give me a second. How can I see if I? Sorry for the screen switching. It's lagging. This is lagging again. Test, test, test. Is the sound? Yeah, the sound seems all correct. I'm such a noob still after so much, after so much streaming already. I should know better. Anyway, I'll go ahead and try to see. So I've got basically the visual code thing here set up. I've got the QDK set up. And I just want to go and see if I can figure out at least how to pass one exercise, because to be honest, it's really cryptic what they are asking here. So it's like the exercise seems to be easy, right? So distinguish identity from X. Just want to kind of keep an eye on the clock because I don't have much time, to be honest, like about 30 minutes, and there's like 16 hours left for the contest for the warm up phase to finish. So I'm definitely not gonna be able to make it through everything. Maybe just 2 or 3 exercises. We'll see. So we're given an operation that implements a single qubit. Yeah, definitely first time, Amir, but I don't have. I thought I'd have more time to go through the warming up, but I kind of a thing with the time zones and all that stuff, and it's pretty late already here. So, but I definitely wanted to try at least do a couple of exercises. I had tried something with Q Sharp about a year ago, but I definitely I was just, I think, reading through documentation, and I think some of the stuff that I'm seeing here in the documentation has changed quite a lot. Why is this keep lagging? Okay, so we need to perform a necessary operation and measurements to figure out which unitary it is. So we return a 0 if it was the identity gate, or a 1 if it was the X gate. So I'm assuming that's as simple as just applying that to a qubit, and if we see the result of the qubit is a 1, then it means it was the X gate, if it starts probably in the 0 state. But how is this going to work? So it should have the following signature. So in here I've got I prepared a solution A1. I guess I'll have to change that. I don't know if this is. I have no idea if this is just something I can play with in the console and then just change the stuff that I need to change. So I'm not so sure about the setup. And then what is it here? So I'm guessing unitary is the actual gate, or the actual yeah. And so my code is applying it. So I've gone through the install. How does this even work? So how Q# programs are structured, qubits, Q# program namespaces, libraries. How do I even build a circuit or something like this? Oh, allocating qubits. Q#, you obtain a qubit The using keyword. You can allocate one many qubits at a time, so you can do something with a qubit. Okay, so we're gonna go in here and say, I'm gonna keep the hello world. So now we have a qubit, and then I'm assuming I have like a unitary, and then I just what do I do? I'm so lost. Oh, come on, exercise. I want to exercise. Include the measurement library. Okay, so I gotta measure stuff. What is canon intrinsic? Those were already there. So I can just copy that. Oh, come on. Oh. So you need a library for measuring. Okay. Okay, then there's an operation. Okay, the entry point. Okay. So you've got like a hotmark. Okay, and then you just return m reset z. That's, I guess, a measurement on the z basis. How do I? This is lagging insanely, people. I'm so sorry for this. So I guess I just have to just let's give it a try. So if I apply, like if I say x to qubit, right, and then return m reset z q, so set z q. Okay. How do I? But how do I read that? How do I know? How do I get the result? Because it just runs the program and does what? Yeah, this is like way too much. Let me take a look at the stream health. Okay, seems all good. So I don't know. Let's give it a try. If I just don't know, if I just terminal, new terminal .NET run. That's probably not going to work because of whatever this is here, unit. So I don't even know where to start. Where is this like a documentation? So how can I just? I don't have anything else on. Like, why is it lagging so much? I have such a bad machine. My it's like the browser is just about to break. I don't know why. Anyway. Blah blah blah. So return the measurement. So you okay? So you're creating operations. Repeat. That sounds pretty crazy. Man, I'm thinking. Yeah, even for the challenge, you're right. So this broke. Yeah, it's not, of course. I think it was result, was it? Yeah. I think I can skip the, or let's just run these again. Was it result? Yeah, result. Measure math. Int. So I don't even know where to. I don't even know where to just. What's next? Like bonus exercise. No. Okay. The Microsoft Quantum Development Kit tutorial or something. The API reference maybe. How do I get hold of the result and or the probabilities? Even. Yeah, that's hello Q as a main. Is the so what is that you're saying? Think of your hello Q as a main that is the verifier, and you solve as the prover method. You can implement. Yeah, but I'm still struggling with just. I just want to get to. Like that's kind of fun. I think I'll figure it out. I just wanted to play with at least how to even get the result. Standard build a quantum. Okay, maybe this should be so result operations using a qubit. For test in set initial let a result. Okay, so you actually the M is the measurement or what? Seems like. What is the M? Before we measure it. Okay, so this is the measurement, and then this is the result. And the output is. Okay, so you can do that. So I could just. C naught result if res equals 1. What is 1? Is it just 1? Is it that we're just measuring one time? So what if I want to measure multiple times? Like the shots kind of concept? That's just my browser is lagging too much. I can't. It's like you might not see it on your end, but I'm struggling a lot to just think clearly because I. So I can measure maybe in a loop, I guess. Yeah, like here for test in account. Okay. I guess so. So you're counting. Oh, that's a good piece of code. So I'm just gonna copy paste that. So this is basically, what is this doing? This is, oh, that worked, by the way. I see one in here. So this gives, this is just one qubit. It's just one qubit, and let's say we're just gonna like test in like 1,000 counts. I can just do one count, to be honest. I think. Because the X gate, I mean, we're assuming no errors in here, right? So I don't think we need these to run. Come on. The lag is incredible. Okay, that's interesting. My mouse is just freezing every second, so, and that's probably why it sounds stupid, but okay, anyway, so we're setting okay, so we don't need, I guess we don't need these, we don't need these, and so here we just need like the X gate. I'm just testing, okay? So then we'll let the result, and then if the result is 1, then we count the number of ones. Yeah, and so and then we set Q0 to 0. Okay, and then we return the so in this case, like, return an int, and then we return, like, you know, we return yeah, I gotta figure out a better way to stream next time. Okay, so this should basically, it's like how many times I get once. I mean, I'm gonna get now 1,000 once, right? So if I do .NET run, I'm gonna get probably, yeah, this is copy-paste programming. So I guess what I'll only have to, how do I, while this is running, so how do Q sharp, like, can I just apply the unit? The question is, can I just apply the unitary? Like, if I'm assuming that this is what's given to me, because I'm assuming that's a unitary, so can I just unitary and call it as a function? Probably, because it seems the parameter is a qubit. I get it. So I can create a another operation that will be kind of the main. Okay, I get it. And so I need to actually do these like that. So that's going to be better. So I kind of, okay, I get it now. The entry point is the main, and so I just do like this, right? And actually, well, it doesn't have to be here. It can be on top, I guess. And so all the code goes probably in, or can just go in there. And then what I just do is in hello Q, I just why does it? Why did it fail? Expecting the type int does not support iteration. Okay, anyway, so can I call? Can I do something like this? Solve, and then give it the X gate or something like. Can I do this? Can I just return this? Okay, so, and this is the solve that returns an integer, and test. Okay, I don't have, no, for this in 1,000. Okay, it's a number. So in I guess I need to, how do I do that? So queue, quantum development kit loops. I guess this is just an array or something. I mean, this was in here. What did it say? Okay, 1 count. So this should be just like that. And now I don't know if this is gonna work, but we can give it a try. .NET run. Okay. Because I guess then all if this works, then all we need to do is we need to change these for a I guess just a unitary can be applied. Oh, I'm stupid. Yeah, okay, but it runs with errors. So what am I? Exactly, I was missing these. So done run. What I will need to replace is the x by unitary simply. Because I can do this already. So I'll change this for that. The result is 1, set num1s plus 1. Okay. Yeah. So, and now we can call this like that with the x as a function like this. Yeah, it just takes way longer than I anticipated to get everything up and running. Come on. Symbol isn't... what? Which symbol? Line 33. These. Can I just return solve x or what? Is there an example here of an operation calling another operation? So it's a bit funky. It feels a bit funky the way this, the way you structure the programs. I haven't played with C# myself in the past, or C or C++, really at the very beginning of my university studies, I think. But then we quickly switched to Java. Okay, so another error, expecting semicolon, great. At line, what line? Yeah, 33. But it doesn't complain about, come on, is the mouse just... Oh. If you guys think that I'm just slow, it's because I keep getting, my mouse keeps getting frozen. It's trimming. Come on, now it should work. So if I get most of them, so I get 1000 shots one, then I'm sure that it's the next gate. If I get like, yeah. Oh, come on. No identifier set 0. Yeah, okay, I don't need to set that stuff to 0. I probably need to import something else for these. But I don't care right now. Run. I should probably run it without, because I think it's already... Can I run it without building it? No, I probably have to build because I'm changing the code. What are the other problems going to be? Come on. Is it Visual Studio Code or something that's freezing the thing, plus the yes, 500. Oh, yeah, 500. Okay, cool. Why 500 though? Wait a second. If I am doing it 1,000 times and I'm passing it the X gate, well, I get 500 once. So this is, it says here in the tooltip, performs a measurement of a single qubit in the Pauli Z basis. I don't get it. If it's just the qubit. Oh, is it because the qubit needs to be reset? That's the reason? So actually that was probably needed. The set part. Q-sharp result. So I think this might be coming from here. How do I... Oh, wait a second. I was using the the reset. Was it like, what was the... It was something that was measuring and resetting the qubit probably in the previous tutorial. In this tutorial. M reset Z. Okay, cool. M reset Z. Let's try now. I want to get 1,000 ones. I want to get 1,000 ones. And then see what happens. And then I guess I can just... and how do I submit that if it works? So the following signature. So they just want these. Can I... So I gotta choose an actual file. Okay. Oh, now I get 1,000. Okay, cool. So what about, I mean, we don't need to do this 1,000 times. We can, but let's leave it 1,000 times. So it's gonna have intrinsic. It can only have these intrinsic. Like, does it have to have only this signature? Can I not just like import here whatever I want? Let's try. So Or can I submit like the whole thing? Or it has to have exactly that signature? Because now that's just an extra hassle formatting every time. But let's... Oh, come on. So I guess as long as the operation solve is there, is good. But then again, I don't need a number of ones. What I need to return is I need to do a really yeah. To be honest, if I do this, that should actually work. Just for this one. Program QS. Okay, so if I choose the file, should I do here? Go to QDK solution A1 program QS, and I submit. How do I know? Okay, so running on test 1, and now it's going to tell me whether they passed or not, I guess, or compilation error. Why? Oh, so it shouldn't have an entry point. Or what? So it has to have strictly that signature, it seems like. It seems it's going to have strictly that signature. If my mouse would move properly, then I would be able to do some work in here. So it's got to have that signature. So problems, A1. And of course I get penalties for that, I guess, which is unfair. Submit. So now it just has these, okay? Return none-ones, which is 0, okay. Running on test 1. Oh, compilation error. That's basically going to be the title of my... If I where the name solve exists. You're kidding me. It says solve. Oh, the namespace. Huh. The namespace. Don't I choose it again? Yes. Come on, running on test 1. It's really about having the right setup, really. What? Wrong answer? Wrong answer on this one. Wait. I need a 0 if it was the I gate, or a 1 if it was the X gate. So I have a unitary. I apply the unitary to the qubit 0. Let the result be M resets at Q0. Then I set num1s to 1. How is that wrong? If I solve for the identity, can this be wrong? So if I solve for the identity and I run, what's it going to tell me? Now I should see 0. Right? If I run the X gate, it's always going to be 1. Yeah, that's 0. If I run it against X, then I won 1. So I don't think this has to do anything with noise or whatever, right? But you've got to be able to distinguish between these two gates. So when I run it against the identity, it return me 0. When I run it against when I solve for X, what does it give me? Why is it so slow? Or 1 if it was the X gate. Yeah, a 1. So why does it fail the first test? Don't I have any example of a test? Wrong answer on test 1. So, um, hmm. The test to perform necessary operations and measurements to figure out which unitary it was and to return 0 if it was the I gate or 1 if it was the X gate. So so you have maybe there is some kind of noise in there, and so I should probably do something like maybe they run it. Yeah, maybe they run it against some. Because I don't know against what do they against what they run this, or would they run this with any kind of simulated noise. So I should probably be a bit smarter and say count these and then say, you know, if the number of ones or return like, you know, like if num ones is bigger than, I don't know, 999, or I'll be like permissive and say like 950 or something, then return 1, else return 0, right? First, let me check that that actually compiles, so I don't get screwed by just stupidity, but like otherwise num ones. Otherwise, what can it be? I mean, so slow. It's a gate. Because the other exercises seem to be similar to this one, distinguishing between different gates: I from Z, Z from S, I and X from C naught. Okay, so this compiles and all that stuff. So if I just save that and I submit this file. I forgot to change the namespace. Can I keep the namespace as it is and it will still run? I think so. So choose submit. in queue. How could I get the wrong answer on test 1? My friend. What? But can you tell me why, or is it that it's like too long or too much memory? And now there's some memory at least. 358 milliseconds. Okay, it's below 1 second and below the memory limit, so... But, I mean, how can I be wrong? So, I can distinguish between the identity and the X gate. That's great. So if I apply the X gate, like M reset set Q0. I'm applying the unitary like 1,000 times. And I mean, that my test here kind of works. I don't know. I don't know where. I don't even know where to start. So the identity gate doesn't do anything to it. Oh, but the qubit can be initialized in the wrong state, or no? The qubit is always initialized at the 0 state. Come on. And I do it here, so I just what does these do? Measure the single qubit base and reset it to a fixed initial state following the measurement. Okay, so that's good. Yeah, I mean, what else can I test here? I just don't know. Like, there's no other hint in here or any example of a test case that I'm supposed to pass. Like, what am I missing? I'm just gonna do this exercise. I'm running out of time. Oh man. So maybe there is something in the announcements or something. Standard input, standard output. Applying the given unitary to it, possibly before or after some other gates, measuring the results and analyzing them. Remember to reset the qubits you allocate to 0 before releasing them. Do I gotta release the qubits, or remember to reset the qubits to your allocated the qubits you allocated to 0 before releasing them. Maybe that's what I'm not doing well then. But it's some other gates. How can I reset the qubits to 0? I mean, I'm doing it every time I measure the qubit. So Microsoft QDK release qubits. Do I maybe need to release them somehow, like dynamically allocated and released? Try a single measurement and see if that works. But I mean, why would a single one work and not like 1,000? Like that would be, if that's the case, I'm quitting, man. Come on, it's like under. No, what am I doing? What am I running these? So I just changed it to one measure, to one measurement, single measurement. Oh, sorry, that should be like this then. Okay, it's bigger or equal, and now it should definitely be a 1. So if I submit these, so Amir is helping me here. Um, hmm. I mean, that would be pretty funny if that's the case. So have I got everything that I need here? Just I'm just doing now one loop if it's one, blah blah blah, and so I'll submit the file, and let's see what happens. Okay, single measurement, see if that works. So I'm planning running on test 1. Well, it's been running longer than the other submissions, so that's kind of good. Yeah, I'll probably do another video. I think I'm gonna just gonna go sleep, man. It's like it's almost 3 a.m. Oh, what the fuck? Sorry. What? How do you accept that? How? The outcome is the same, man. Why wouldn't they even care? Like, I'm not even, like, it's 300 milliseconds. It's not even a second. I mean, dude. Please. Like, come on. I'll see if I can submit a couple of other. I think the other ones should be fairly similar. If the mouse would move, just move. Sorry, you probably see the mouse moving, but I don't. So I from Z. Okay, that should be easy. I'll do without submitting. So first, if the I from the Z, right? So if I first apply a Hadamard to the qubit, then I apply the unitary to the qubit, and then I apply another Hadamard to the qubit, I can distinguish, because if this is a Z, if this is a unitary, if this is the identity, it goes back to 0. If it's the Z gate, it goes to 1. So what I need to know is they want a 0 if it was the identity, or 1 if it was the Z gate. So that should work out of the box. Bam. Come on. Those are easy. Those are easy. But one single measurement versus 1,000, it's, come on. Analyze the qubits. What? Semicolons. Semicolons. Now. Get it. Get it. Get it. Get it. Get it. Come on. What's the other one? The Z from the S. The way I could do this is if I apply the Z from the S, right? So if I apply Yeah, accepted. So if I apply come on. So the S from the Z. So if I apply first NAS gate and then another and yeah, if I apply a NAS gate and then it turns out it's a hardmark and NAS and then it turns out it's a NAS, then I'm gonna get 1. So if I do here a hardmark gate, a NAS gate, right? So if the unitary is an S, and then I do another hardmark gate, and I'm gonna get a 1 always. If it's a Z, then I have still 50% chances of get no 50% chances. I'm not gonna get. What am I gonna get? Like if I let me go to quirk. So if I'm in the I state and apply a hardmark gate, then I've got that, yeah, 50-50 chances. So what I would say here is that if the resolution is if the result is 0, if I find a 0, if I run these like say 10 times, okay, if I find a 0, let's say 100 times, if I find a 0, then I got like non-zeros in here. So if num0 is 1 or more, then return a 1 because it was a and not then return a 0 because it was right. I want 0 if it was a Z gate because then it was a Z gate. If not, if I don't find any zeros, it means that it was a yeah guys. I think I have to go. It's too late. It's a bummer that I spent too much time just because I was running the circuit 1,000 times. But come on, let me finish this exercise at least. Mouse, let me finish. Okay, so if I find a 0, it means that it was the Z gate. If I don't find it, it had to be the S gate because S and then hardmark turns into always 1s. Okay. If I have time when I wake up tomorrow to do some more, then I'll try to submit a video or something. That should work. Yeah, but that was a bummer. Come on. Accept it, baby. And we'll go. And go. What? Wrong answer. So num0 is 0 if the result is 0. If I find a 0 in these like 100 runs, right, it's because there was a Z gate in here. Yeah, I don't know. Like I don't trust that anymore. If that's somehow the number of measurements messes these up. Anyway, I'll just finish here because I really run overtime. I gotta get some sleep. And actually, yeah, there's still 15 hours, so I might do something tomorrow in my morning. I'll see. I don't know. Just want to make sure. Maybe I'll do them anyway, even without submitting, so I get used to the environment for the competition. But that can be a really interesting one. Anyway, thanks for whoever joined, and yeah, stay tuned. I have to fix my performance problems here with the streaming, but I hope it was fun. Yeah, cool.